Question number 6. A system that consists of a single spring stores an elastic potential energy EP. So for this one, elastic potential is given. What is EP? EP is nothing but half k x square. We already know this. When a load is added to the spring, the another identical spring is connected in parallel to the system. Okay. If I have a convention like this, the same load is now applied to the parallel springs. Now, if the same load is applied, okay, first what we'll do is, if I apply a load over here of mass m, mg would be the force acting downwards. So if it is in equilibrium, what will happen here? I can now write, let me say mg is equal to some f here. Okay, I can now write kx is equal to f, x is equal to f by k, and thus I can now substitute this value. I can write EP is equal to, or E1, instead of writing EP, I'll write E1 is equal to half k into f square by k square. This k and this k goes away, so I get half, or maybe I'll write f square divided by 2k. This is what I get here, right? Okay, so what is this now? The energy as seen for the first spring. Now let us take a second spring. When I take the second spring, now what will happen to the load? When I add the same load over here, now both of them are taking the same load. It is like having, let us say, I have a rubber band. Put one load here, it will extend like this. Now if I take two rubber bands over here, what do you think the extension would be? Extension will not be so much. The extension would be a little bit lighter over here. Why? What is the reason? Reason is because it observes that there are two supports over here. The weight is being supported by two rubber bands over here. Tension is being changed, right? So as a result of it, it will not extend so much. There is a new extension that you get here. You cannot use the same value here. Now, so therefore, what we do is, let us say this has an extension, or this has an upward force kx, and this supports by a force kx because identical springs. I can now say 2 times kx is equal to the load f over here, or x should be equal to f by 2k, right? Next, what I should do? I'll find out the E2 value, the energy in the second configuration, which should be half k into f square divided by 4k square, right? When I do this, what do I get here? Let me simplify this. So what is this now? This is nothing but the energy in one of the spring. Now I have two springs over here, right? So what I should do? The total energy E2 will now be equal to 2 into half k into, oh, I put something here. Okay, I put ek dash here. Is equal to half k into f square divided by 4k square. When I do this, what do I get? 2 and 2 goes away. I am getting this as, this k and k also goes away here. I am getting this as f square by 4k. Now compare between these two. This E1 is f square by 2k and this E2 is f square by 4k. What will this become? This will be E1 divided by 2. Okay. So thus the answer should be E1 by 2, answer is B.